Hi, this is lesson 13. These are word problems. So this is basically how we are going to apply some of the things we've learned in this quadratics unit. And I will model let's see how many there are. I'll go ahead and try to model all the odd numbers for you. Okay, so let's begin. So notice these are geometric applications, so area problems. Given this diagram below, which is a rectangle, find the value of x if the area is 78. So I like to put 78, whatever the area is, in the middle of that. And now I'm going to set up this quadratic. And you may think to yourself that maybe this isn't a quadratic, but once you will realize, once you multiply it out, that it is a quadratic. So here we go. So to find the area, well, I'm going to multiply the two sides together. So I have x times x plus 7. Now, when I multiply these two sides together, I get an answer of 78. Okay, so what I'm trying to find is x. So let's go for it. So I'm going to multiply this out. So x squared plus 7x equals 78. And then I want to turn this into a trinomial and see if I can, because I have an x value, so I can't do some of those strategies like complete the square or square roots. Because I can't do complete the square because that's odd anyway. But I'm going to go ahead and turn this into standard form. So x squared plus 7x minus 78. And I'm going to set that equal to 0 because I'm trying to solve it. So here I have this quadratic, and I am going to do the product sum game. So I want to multiply two numbers to get to negative 78, and I want to combine them to get to 7. So they have to be 7 apart. Well, if I Google what are the factors of 78, that could help me, but I do know that 6 times 13, when I multiply them together, is 78. So I'm going to do, and it's going to be a positive 7. The difference is 7. So I'm going to have positive 13 and negative 6. Okay. I'm going to go ahead and factor this into x minus 6, x plus 13, and again set it equal to 0. So now I'm going to factor both sides out by setting to 0. And hopefully you are really getting into the routine of realizing that if you have a negative factor here, it's going to be a positive solution. And if you have a positive factor, it's going to be a negative solution. And this is kind of interesting because what I'm looking for in most of these problems is a positive solution, because I can't have a negative value for x. If I had a negative value for x, it really wouldn't necessarily exist in this expression here. So I'm going to look for the x is equal to 6, because that's the positive one. So x, the answer, is equal to 6. And notice it's meters. So if I wanted to be even more precise, I could add 78 square meters. And then the answer is that x is equal to 6 meters. Okay, let's go down to number 3. Okay, number 3, find the dimensions of the rectangle below if the area is 128 square feet. Okay, so when I multiply these together, I'm going to get 128. So x minus 1 and x plus 7. Okay, so when I multiply these out, I FOIL them. I'm going to get x squared plus 6x minus 7. And again, you're going to FOIL that, so check your answer. I'm not showing every single step here. Equals 128. And then I want to move the c back in over here to standard form. So I'm going to subtract my 128 from both sides. So I'm going to end up with x squared plus 6x. And then negative 7 minus 128 is negative 135 equals 0. I'm going to factor this out. So product sum to negative 135, and I'm going to combine to 6. And when I Googled that, I got 15 and 9 as good factors that when I combined them, I got to 6. So if it's positive, then my higher number has to be positive, and then I'm going to have a negative 9. Okay, so I'm going to rewrite this as x plus 15, x minus 9 equals 0. And this over here can't be a solution. So I'm going to start just putting an x through or slashing it. X equals 9, that's a positive solution, so that is going to work. So if I have x is 9, oh, sweet. Okay, so then I have to, it's asking here, find the dimensions of the rectangle below the areas. Okay, so the dimensions are, well, if x is 9, then this itself is going to be 8. So 8 feet is going to be this dimension, and the other dimension, which is going to be 9 plus 6, is going to be 16. These are the two dimensions. Okay, number 5. So for number 5, I have the length of a rectangular garden is 4 meters more than its width. The area is 60 meters. Find the dimensions of the rectangle. Okay, so I have a rectangular garden. So I'm going to say let x equal the width. And then x plus 4 is going to be the length. Okay, so I could, in fact, draw the length of a garden, right? I could write something like this. So the length is 4 meters more than its width. So I could draw it like that. And then the area is 60 meters. Okay, so here we go. So I'm going to have x times, because I'm going to multiply these together. Oh, and then I have some more information. So that's my area. Okay, so x times x plus 4 is equal to 60. And now, if I distribute this out, wink and smile, I'm going to end up with x squared plus 4x minus 60. I'm going to move the 60 over this side. Okay. Now, if I do the product sum game, I'm trying to get to negative 60, and then I'm going to combine to 4. And I know that's going to be 10 and 6. And what's going to be the negative? Well, let's see, positive 10 and negative 6. And yep, that's going to work. Put it in my template. X plus 10 and x minus 6 equals 0. Now, I already know this is going to be a negative solution, so x equals negative 10 is not going to work, but x equals 6, that will work. Okay? So it's asking for the dimensions, so I have to plug in 6 again to these values here. So first of all, x is equal to 6, so I have, the dimensions are 6 by, I'll put a comma for that, and then if I have 6, I'm just going to substitute back in, plus 4 equals 10. So this is going to be a 6 by 10. Okay, next page. On the back. So maybe I'll try to zoom in a little bit. So on the back, I have a square is altered so that one dimension is increased by 5. The other dimension is decreased by 2. And the area of the rectangle is 98. Okay, so let's draw a picture of this. So first of all, let's let x equal one of the sides of the square. And let's see, x plus 5 will represent the rectangle side. And then x minus 2 is the other rectangle side. So I'm going to draw a picture of this now. I have a rectangle here. Okay. And let's see, I have on the bottom, let's make that one because it looks a little bigger, x plus 5. And let's make the side x minus 2. Oh, here. Okay, that's a little better. And then when I multiply these two together, I'm going to get an area. Let's see, it gives us, the area of the resulting is 98. So I'm going to put 98 inches squared. Okay, and it says find the area of the original square. Oh, that's pretty cool. Okay, so let's go ahead first of all and solve for x. That's our first job. Okay, so if I look at solving for x, well, I have some knowns, so I'm going to go ahead and I'm going to start with this. X plus 5 times x minus 2 is equal to 98. I am going to subtract 98 from both sides. When I FOIL this, I am going to end up with x squared plus 3x minus 10. So you can check my work, but that is this trinomial when I FOILed this, distributed it out together. Now I am going to subtract the 98 from each side. And I'm going to end up with negative 108 and 0 on the right. Okay, so when I factor this out, product sum, notice how much we do product sum, a lot. I need factors of 108, they're 3 apart, and I know my 12s and my 9 table pretty well. So I think it's going to be 12 and 9. The middle term is positive, so that's going to mean I have a positive larger number and a negative smaller number. That's going to work. So x plus 12 and x minus 9 equals 0. Okay, so what are my positive solutions here? Well, x cannot equal negative 12. It does equal negative 12, but that can't be a solution. X equals 9, that is a solution. So let's go back to the original question. It said let x be one of the sides of the square. So if I draw that now, well, now x times x, right, is a square. I know that x equals 9. So I can go ahead and substitute 9 for x, and 9 times 9 is 81 because it's asking for the area of the original square. So the answer is 81 inches squared, and that is the area of the original square. That's pretty neat. Okay. Let's look down here at number 9. So for number 9, I have the product of two positive. So I'm adding a lot of the things I've learned in the past also. The product of two positive consecutive integers is 56. Find the integers. Well, let x is going to equal the first number. I'll just call it that. Integer, consecutive integer, what have you. And then x plus 1 equals the second number. And now I'm going to put some of these pieces together. The product, so of two of these, is 56. Okay, so I'm just going to go ahead and multiply. So the product, one number is x, and the other one is x plus 1. When I multiply them together, I get 56. Now I'm just going to solve. So I'm going to wink and smile. So I have x squared plus x equals 56. I'm going to subtract to get that on this side. I'm going to factor this out. I have negative 56, and I'm going to combine to 1. So one of these has to be positive. Okay, so I'm going to have positive 8 and negative 7. That's going to work. Okay, so now I have x plus 8. And then I have x, let's see, minus 7 equals 0. And I'm looking for a positive solution yet again, right? X is equal to negative 8. X is equal to positive 7. And I can only have a positive, because that's what it told me, integer. That's out of the game, out of the running, right? So x is equal to 7. Now the question asks, what are the two integers? So if x is 7, then that's the first integer, first number. And the next number, I'm just adding 1. So the answer is 7 and 8. Last but not least, I have number 11. So we're going to do, this might get a little trickier, but you can do it. Okay. Find two positive consecutive odd integers such that the square of the first, oh, holy cow, that is really complicated. Well, let's start with, let's define our x. Let x is equal to the first positive odd number. And I'm using that for number or integer, okay? But remember, they have to be positive numbers. Now let x plus 2 is going to be the second positive odd number. Okay. So now I have to find two numbers. So the square of the first, okay, well, let's take this apart. The square of the first, I can represent that as x squared, okay? So I just kind of took care of that. Added to, so I know I'm going to need a positive sum. So added to 3, so I'm just translating this into parentheses and operations. Added to 3 times the second number, which is x plus 2. That's the second number. So I'm literally taking every word in here and I'm translating it. And now that's all equal to, because is equal to 24. Now I get to solve. So I hold on to my x squared. Wink and smile this out. So I'm going to get 3x plus 6 equals 24. Now subtract 24 from each side. Rewrite x squared plus 3x minus 18 equals 0. And now let's factor it out. I'm going to have, let's see, can you see that? Yeah. I'm multiplying to negative 18. And I'm combining to 3. So I should have 6 times 3. And are they both going to be even, odd, positive, negative? What am I doing here? I should have a negative 3 and positive 6. Okay, so let's rewrite. X plus 6 and x minus 3 is my answer. And if I automatically see this and I see, well, x is equal to negative 6, can't be negative. X minus 3, well, x is 3. That's my solution. So that has to be my first number. So x is equal to 3. So my first number, I'll move this up, is my first integer is 3. Remember, my second integers, I'm just adding 2. So my second integer in this problem has to be 5. Okay, I hope this helps. This would be a good one, like, as you start to do the other problems. Definitely look at the answer key. Maybe I'll do another video with the other, the even numbers. I'm not sure, but I think this is a really good start for you. Good luck with this.